Let me start with a question. What if your code could find and fix its own security vulnerabilities?
That's exactly what the Codex Security repository does. It's a CLI and TypeScript SDK that uses AI to scan your code for security issues, validate them, and even apply patches automatically.
So, who is this for? What kind of problems does it solve?
This is for developers and security teams dealing with application security. It solves the problem of manually finding and fixing vulnerabilities, which is time-consuming and error-prone. It automates the detection and remediation process using AI, making it much faster and more scalable.
How does it work? What makes this different from other code scanning tools?
What sets this apart is its use of AI, specifically through the Codex engine. It doesn't just find vulnerabilities, it can also generate patches. This is a big shift from traditional static analysis tools that only identify issues without offering solutions.
I see. Can you explain the technical approach, especially the AI integration?
Sure, the tool uses AI models to analyze code and detect potential vulnerabilities. It can even apply patches based on the findings. This is made possible by the Codex engine's ability to understand and manipulate code, which is trained on a vast amount of code and security patterns.
That's impressive. How does it handle the scanning process? What are the key components?
The scanning process is handled through a CLI and a TypeScript SDK. The CLI allows developers to run scans directly from the command line, while the SDK can be integrated into larger applications or CI/CD pipelines. The tool also supports various configuration options, such as scan depth, severity thresholds, and model selection.
I'm curious about the architecture. What are the key design decisions that make this work?
One key design decision is the use of a modular architecture. The tool is split into components that handle scanning, patching, and reporting. This modularity makes it easier to maintain and extend the functionality. Another is the use of a plugin system, which allows for custom scanning rules and integration with other tools.
That's interesting. What about the integration with other systems or tools?
The tool integrates seamlessly with GitHub through the ability to create pull requests directly from the scan results. It also supports multiple inference providers like OpenRouter and Fireworks, giving users flexibility in choosing their preferred AI model.
What about security and access control? How does it handle sensitive data?
Security is a top priority. The tool uses environment variables for API keys and never stores them in the system keyring or any persistent storage. It also supports secure scanning configurations through AppArmor and SecComp, ensuring that the scanning process is isolated and controlled.
That's reassuring. Are there any limitations or caveats that users should be aware of?
One limitation is that the AI-generated patches may not always be perfect. They require validation and review, especially for complex or critical vulnerabilities. Additionally, the tool relies on access to codex security, which may require approval through trusted access for cyber.
So, what's the overall impact of this tool on the development process?
This tool significantly reduces the time and effort required for security scanning and remediation. It allows developers to catch vulnerabilities early and apply fixes automatically, reducing the risk of security breaches and improving the overall quality of the code.
Can you give an example of a typical workflow using this tool?
Sure, a typical workflow might involve running a scan with the CLI, reviewing the findings, applying patches for high-severity issues, and then creating a pull request for the fixes. This entire process can be automated in CI/CD pipelines for continuous security checks.
I see. What about the performance of the tool? How does it scale?
The tool is designed to scale well, especially with the support for multiple workers and the ability to process large repositories efficiently. It also has built-in limits to prevent excessive resource consumption, such as a maximum scan time of 96 hours, which can be adjusted as needed.
That's a smart design choice. What about the user experience for someone who's not familiar with the tool?
The CLI is designed to be user-friendly, with clear commands and options. The interactive scans guide users through the process of reviewing findings and applying patches. There's also extensive documentation and examples to help users get started quickly.
What are some of the technical challenges that the team faced while building this tool?
One of the main challenges was ensuring the accuracy and reliability of the AI-generated patches. Another was integrating the tool with various environments and ensuring compatibility with different setups, such as Docker and CI/CD pipelines.
That makes sense. How does the tool handle different types of vulnerabilities and code bases?
The tool is designed to be flexible and can handle a wide range of vulnerabilities and code bases. It supports multiple programming languages and can be configured to focus on specific areas of interest, such as high-severity issues or particular types of vulnerabilities.
Are there any plans for future improvements or features?
The team is continuously working on improving the tool, including enhancing the AI's ability to generate more accurate patches and expanding support for new languages and frameworks. They're also focusing on improving the user experience and making the tool even more accessible to a broader audience.
That sounds promising. Who should actually care about this repository?
Developers and security professionals who are looking to automate their security scanning and remediation processes should definitely care about this repository. It's a powerful tool for anyone serious about application security.